So for my physics project, I made a ball launcher. So I started out with this tube and I stuck 2 hooks on the sides. And then I also glued 2 bottles together with a bungee cord at the bottom. So basically what happens is these bottles will go in at the bottom of the tube, and the 2 hooks from the bungee cord will get hooked on to these hooks. And then you can stick a ball in at the top and hold it at an angle, and when you pull back on this part, it should project the ball out of the tube. And the next part will be a demonstration. The first physics concept is projectile motion, which is the motion of an object projected into the air, and once it's in the air, the object is only subject to the force of gravity. So in my project, once I released the bottles, they pushed the ball out of the tube, projecting it, and the ball followed this path called a trajectory. After the initial force of the bottles on the ball only had the force from gravity pushing it down to the ground. The second physics concept is force, which is something that's exerted on an object to change its motion. So in my project, the applied force are the bottles that push on the ball, and the forces from the bottle cause the ball to shoot out of the tube, changing its motion. So once the ball is out of the tube, the force from gravity pushes the ball down onto the ground. And there's also the force of friction present when the ball is in the tube coming out of the tube, because as the ball comes out of the tube, the friction from the tube is slowing it down. So the next physics idea is velocity, which is the rate at which a position changes, or the speed of an object with direction. So in my project, the initial velocity is 0 meters per second because the ball is at rest, and the final velocity is the velocity of the ball right before it hits the ground. And also, when the ball is in its trajectory at the highest point, the velocity is 0 meters per second because that is the Vmax. So the fourth concept is angular launch, and this is when an object is launched at an angle, and this angle determines the range and the height that the object goes. So in my project, I measured the angle to be about 22 degrees, and I found that the smaller angle caused the ball to launch and go a further distance, whereas a larger angle caused the ball to go higher. But launching at an angle allowed the ball to move in kind of like a semicircle path instead of just a straight line. Newton's first law says that the motion of an object will remain the same unless it's acted on by an unbalanced force. So in my launcher, the ball stayed at rest until the force from the bottles acted on it. And this relates to inertia, which is the resistance of an object to change its velocity. So if there's more inertia, an object's motion will change less when a force is applied. Since a tennis ball doesn't have a large mass, it didn't take much force to change its motion. But if it had a greater mass and more inertia, more force would be necessary to move it. Newton's third law says that for every action there is an equal and opposite reaction. So when I pulled the bottles back with the bungee cord as the ball was placed on top of them, that was the first action, and the opposite reaction was the ball leaving the tube. So the force from the bungee cord and the bottles was equal and opposite to the force that projected the ball forward. The next concept is kinetic energy, which is the energy of motion of an object, and it depends on the velocity and the mass of an object as seen in the equation above. So once the force caused the ball to move out of the tube, the ball had kinetic energy because it was moving. So this also relates to the law of conservation of energy, because if the initial and final kinetic energy of the ball were equal to each other, this would be an elastic collision and energy would be conserved. But in this case, the initial velocity is different from the final velocity, since the ball is being launched from a different height than where it lands, so the final and initial kinetic energies aren't equal, so this is an inelastic collision and energy is not conserved. The last term is elastic potential energy, which is the energy stored in elastic materials when they stretch or compress. So in this project, the elastic material was the bungee cord, and when it was stretched, it had potential energy, but when it was released and it went back to its original shape, there was no longer potential energy there.